So this video is a review of our 6 trigonometric functions. So we have sine, cosine, tangent, cosecant, secant, and cotangent. And O here is opposite, A is adjacent, and H is hypotenuse. So sine theta is opposite over hypotenuse, so it'd be opposite over hypotenuse. And then so on. Cosine theta is adjacent over hypotenuse, and adjacent is the one next to the angle. Opposite is the one opposite, literally. And then H is our hypotenuse. It's always our longest side. So we're going to write our 6 trigonometric functions for this one. So we have sine theta right here, and sine theta would be opposite over hypotenuse. So our hypotenuse is missing, but any right triangle, we know that a squared plus b squared equals c squared. And all of this stuff is only good for right triangles. So we plug in 3, we plug in 4, and then this would be 9 plus 16 equals c squared. And then we continue to solve. Square root, square root. Now all our sides are always positive, so we don't have to do plus or minus. Our c, that is, for right now, is hypotenuse. So it'll always be positive. Okay, so then sine theta would be opposite over hypotenuse. And again, this is opposite. This is adjacent. And this is our hypotenuse. And again, adjacent is right next to it. Opposite is literally opposite, and hypotenuse is the longest. So opposite would be 3 over 5. Our cosine theta then would be adjacent over hypotenuse, so that would be 4 over 5. And then tangent theta is opposite over adjacent. That's our SOHCAHTOA. So you can remember it, SOHCAHTOA. And so TOA, tangent, opposite, adjacent. So that would be 3 over 4. And then each of our reciprocal identities. So cosecant is the reciprocal of sine. You just flip them. Secant's the reciprocal of cosine. So we flip them. And cotangent's the reciprocal of tangent. So they flip. So now we write cosecant theta, and that would be 5/3. Secant theta, and that would be 5/4. So all I'm doing is flipping their reciprocal identity. So cotangent theta is 4/3. And there you go. That is all 6. So we use Pythagorean theorem to find the missing side, and then go for it. So let's try another one. They're all the same. So cosine theta is 9 over 40. So then we draw first a triangle, and you put theta. And again, cosine is adjacent over hypotenuse. So that means this is 9, and this is 40. So what we're missing is the opposite. So again, a squared plus b squared equals c squared. We'll call that one b. So 9 squared plus b squared equals 40 squared. And then this is 81. This is 1600. And this equals 1519, square root, and so b is approximately 38.97. Now we want to find exact values as well here. So b equals the square root of 1519. So if we take our calculator, you want to just look at 1519, and you start dividing by primes to see if it'll simplify. So we know 2 is not going to go into it. And if you add up the digits, 3 is not going to go into it. The next one's 5. 0 and 5 is not going to work. And so then we test 7. And you just keep working your way up. 7 does. So we test it again to see if we have a pair. And we do. So this is 7 times 7, and 31 is also prime. So this would be 7 times 7 times 31. So that would be 7 square root of 31. And that's what we want to use here. So 7 rad 31. And so now we can say sine theta, cosine theta, tangent theta. And sine would be 7 square root of 31 over 40. Cosine theta is 9 over 40. And then tangent would be 7 square root of 31 over 9. So again, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Those are all of them. And then we flip them. So again, cosecant theta. And the way you kind of remember it, you think, oh, secant would be the reciprocal of sine, and cosecant for, no, they're backwards. So just think of it that way. Cosecant is for sine, and secant is for cosine. And then tangent's easy because he's just cotangent theta. And then we flip them. So this would be 40 over 7 rad 31. And then we need to rationalize. So square root of 31, square root of 31. and we end up with 40 square root of 31 over, remember this will now be 31 times 7. So 31 times 7 is 217. And then we do it again. So this is 40 over 9. Don't have to do anything. And then 9 over 7 square root of 31. We rationalize. And we get 9 square root of 31 over 217. And there you have it. That is all 6 trig ratios. Okay, so the last one is yours to try. This is a cosecant. So again, we go back and look. Cosecant is the reciprocal of sine, so it is a hypotenuse on top and an opposite on the bottom. So this is our hypotenuse over opposite, and I want you to give it a shot. So hit pause now and try it. Find all 6 ratios from that. Hit pause now. And so these are the 6 trig ratios you should have gotten. Take a look at it. Hit pause. All right, thank you.